Okay, so this is the recording moving on for 10-4 hyperbolas, and I'm going to go very quickly through these slides because we've already written them down while the other recording was, excuse me, um, well, saving itself. So here are the objectives we're going to work on: writing equations in standard form, finding asymptotes, and graphing hyperbolas, and a little bit of classifying conic sections that we've kind of had as we go through. Just a reminder, a hyperbola, absolute value of the difference of the distances between foci and a point on the hyperbola that is fixed. We just defined a hyperbola, so I'll leave that for you. You can pause this if you need to see that a little bit longer. And now we're just kind of saying some things about the parts of a hyperbola. The graph of a hyperbola has two disconnected parts called branches. So just a little bit of terminology. The line through the two foci intersects the hyperbola at 2 points called the vertices. So those are the 2 points that we're going to have. And the line segment connecting the vertices is the transverse axis, and the midpoint of the transverse axis is the center of the hyperbola. And so on the next slide, we'll kind of label those things using kind of a picture. And so this is some pretty important stuff that you want to draw. I'm just going to point out, and since I have people gone, I'll just kind of trace over. So we've got a center just like before. We've got two vertices along that line, and then notice that our foci are outside of that area, and this one is kind of shown horizontally. The center again is H comma K. The vertices are at H plus A comma K. And H minus A comma K. And then the foci are at H plus C comma K and H minus C comma K. So once we get those, and to be honest, when we're sketching our hyperbola, we're really just going to have that center, the vertex, and the center, the two foci, and the two vertices, and then we're just going to kind of draw it out from there as we go. Then notice that the center is at the midpoint of the segment joining the foci. So, you know, that's kind of a good thing to kind of notice as we go through this. And then if you remember that distance that we're using, kind of that idea of that string kind of thing, these distances that we're subtracting. One of the distances is from a vertex to the foci, and if we were kind of looking at the one to this vertex that's right here in red, I just highlighted it, that might be one of the distances. If I'm right here, my other distance then goes from this point out to this other focus point that's right here. So we could say D2 is from there to there. I'll call that D2. And then D1 is just from there to there. D1 is from there to there. And remember that it's this absolute value of D2 minus D1, oops, absolute value, that d2 minus d1 that is constant as we look at that. And so we can use that to kind of derive how long that is. And it is going to be this distance of 2a. And I'm going to show you visually on here. Maybe it's a little harder if somebody's not in the room. But just look at this picture a minute. So do you agree if I take D2 minus D1 that kind of this is the overlap part right there, that if I subtract it off, it's the same as that part? Does that make sense to you? And so this is the length of that, and since there to this, from the center to that vertex is considered A, then this distance is 2A. Does that make sense to you? That D2 minus D1 in absolute value is equal to 2 times A. And I'm going to get rid of all that yellow stuff. But the book authors are showing that in just a little different way. So, you know, kind of taking this minus this all minus that, and that's 2a. So that's something you want to know, and I'll just kind of highlight that right here, that d2 minus d1 in absolute value is equal to 2a. Just to kind of let you know, you might want to have that written down someplace, just to kind of know where some of these things are happening. So the development of the standard form of the equation is for a hyperbola is similar to an ellipse. We were not going to go through that process, but here are our standard equations of hyperbolas. And I want you to notice some of the differences as you're writing this. And for those of you in the room, I'm just going to let you write that down, and I think we'll be done for the day. What is a big difference? Anybody noticing a big difference, or the big difference? The squared part, is it a lot different than an ellipse? How is this different than an ellipse? It's subtracting instead of adding. And so be careful and just take a few minutes. And then also the vertices are A units from the center, and the foci are C units from the center. And now C squared equals A squared plus B squared. And so I'll let you write that, and then tomorrow we'll do some problems, and then you'll start on work time, and you can be looking at your review problems.